My name is Xueze, and with me is Wei Pin. This is a presentation of our mini project, Spotify Analysis, where we look to find undervalued songs.
Ever heard of this song?
I do the same thing I told you that I never would. I told you I changed.
Newest hits by the hottest artists. Shopping malls and eateries only play the most trending and the most hip song. Don't we all get tired of hearing them after a while? We want to know what makes a song popular, and beyond that, a chart topper, and then proceed to flip all of that upside down. We want to uncover the overlooked, the misunderstood, the underrated. Songs that deserve their limelight to be played down the supermarket aisle and up on air. Here's to the undervalued songs. To measure our success, we want to produce 3 different playlists. First, the overlook, a playlist of songs that had the hype but just wasn't enough. Next, the ones that got away, songs that had the desired audio features but slipped under the radar. Lastly, the underrated, fulfills the taste of the masses but just couldn't get over the line. We found 3 different data sets from Kaggle to help us with this project. Global Weekly Top 200 for our hit songs, Spotify features to help generate the audio features, and tracks to uncover our diamonds. Before using the dataset, we first had to do some preparations, starting off with understanding exactly what we can do with our data. We then created a hit dataset by extracting songs that were both in our song bank and in our dataset, a hit dataset. We then created a non-hit dataset to complement our hit songs, and this was based on the assumption that songs in our song bank, but not in our hit songs, were just not hits. We then merged the hits and the non-hit subset to form our working dataset. To form our prediction dataset, we took the remaining songs from the song bank for our model to run on. Next, we take a closer look at our hit dataset. Taking a look at the distribution of streams, we notice that there's a substantial amount of hit songs with abnormally high streams. I guess this is thanks to the shopping malls and the eateries. The distribution of popularity doesn't seem out of sort, except for the fact that there exists a hit song with zero popularity. We also took a look at the top 3 performing artists, and it seems that XXXTentacion had too short a career. The top 3 performing genres doesn't come as a surprise.
Moving on, we formulated 3 different problems to find patterns among popularity, hit status, and audio features. First, we explore the relationships between popularity and hit status. From both the KD and box plots, we see that hit songs generally have higher skewed popularity distributions than non-hit songs, but they do overlap at popularity scores of around 50 to 85, so these are the songs that we are interested in. We then use a decision tree model to see if popularity scores can be used to predict hit status. Our high classification accuracy suggests that we can. We are interested in the false positives, songs that were not hits but predicted to be hits by their popularity. So using the tree model, we try to find non-hit songs that should have been hits based on their popularity. These songs deserved a place in the top charts but were robbed. They were overlooked. After running our model on the prediction dataset, we observed that songs with a popularity score of 0 were being predicted to be hits. This is odd and shows that our model might not be accurate enough, and there might be a case of overfitting. So we looked to other models instead to see if we could yield better results. We decided on random forest due to its ability to avoid overfitting. We were hoping that it would be more accurate and avoid the edge cases of extremely low popularity songs being predicted as hits. After applying random forest, our classification accuracy was not much better than the decision trees. And there were still songs with 0 popularity being hits, although only a few. Our deduction was that since the model was trained on data that had some hit songs with very low scores, we would expect to see low popularity songs predicted as hits. However, the model does not determine a hard cutoff point to stop considering a song as a possible hit. So we concluded that these results were extreme outliers that were inevitable from our model. Still, logically, it is impossible for songs with extremely low 1-digit scores to be hit songs. To exclude these extreme outliers, we generated our playlist based on the top 20 predicted hit songs with popularity just below the median. Next, we compare audio features and hit status to find out which audio features were most important in determining if a song was a hit. We looked at both numerical and categorical features. Numerical features. From the box plots, it is hard to visibly tell the relationship between audio features and hit status. So we use decision trees to quantify these relationships by finding the classification accuracy of each individual feature. While it seems like none of the features are able to accurately distinguish a song as a hit, we take the top 3 features with highest accuracy to train our model. Among the categorical features, only the key of the song appears to affect the song's hit status. However, we cannot visualize the relationship between two categorical variables, and so we chose not to use them. With another decision tree, using the top 3 audio features, we find the songs that sounded most like hits but somehow did not make the charts, the ones that got away. We see that the classification accuracy is not very high, as the accuracies of each individual feature were low to begin with. At least, the accuracy of this model is higher than that of any individual feature. So we generated another playlist, again using the top 20 songs below the median popularity to avoid outliers. This playlist actually has some pretty good songs that we've never heard before. Lastly, we look into relationships between audio features and popularity. Looking at the numerical features and plotting them in a correlation heat map, we observe that there is poor correlation between all the features and popularity scores. So we chose the 3 features with the strongest correlations, which are loudness, acousticness, and energy. Again, the categorical features did not offer much insight, so we did not use them in our predictions. We try to predict a song's popularity score based on its top 3 audio features. We then find the songs that were predicted to be popular yet did not receive as much love in actuality, the criminally underrated. To train our models, we used the whole songs bank for more data points and not the working data set. We first tried to use linear regression, but the model had a poor fit for both train and test datasets. Explained variance was low and mean squared error was rather high. Perhaps a continuous popularity score from 0 to 100 is too difficult for the model to predict. Classification into discrete categories could be a better option to allow more space for the model to maneuver. So using the pandas cut function, we split the dataset into 3 classes by popularity score, with even ranges in each class. Hence, each song now had a discrete popularity score out of 3 stars, which resembles more of a rating system. The songs we are interested in are those like song A and song C, which have predicted popularity ratings higher than actual. Now after splitting, we see that the bins have unequal number of songs in each category. To ensure that the data fed into classification models is balanced, we use random oversampler to resize the unevenly distributed classes. Upon running the first KNN model, we get a suspiciously good accuracy score of 0.72. We suspected this was a case of overfitting, so we used grid search to find the optimal n neighbors. Feeding the optimal n neighbors of 23 back into the model, we get a more realistic accuracy of 0.61, which despite being low is still much more promising than linear regression. Since we used the whole songs bank for training, we did our predictions on a separate dataset of songs of similar size. Finally, we generate our playlist by taking the top 20 songs with the highest predicted popularity, where the predicted popularity was higher than the actual. The resulting songs had a mix of old songs by famous artists, less known songs, and obscure non-English songs.
With all that analysis and code, we look to deliver what we promise. Our final result comes with 3 different playlists. Feel free to scan the QR code to access our playlist. For each playlist, we collated the top 20 songs in terms of popularity via a Spotify API call. This unfortunately still leaves out a good amount of songs that are waiting to be uncovered. After generating our playlist, we had a few interesting notes. Due to the nature of Spotify removing older songs from their hit list, our non-hit dataset contains older hit songs. However, our model was able to pick them out and reclassify them as hit songs. Such songs included The Middle by Z and several of Selena Gomez's old hits, highlighting the effectiveness of our model. We also noticed that several songs in our playlist were non-English and presents to us the sad truth that language barrier still stands in the way of many artists. The best part about this project is that we answered our initial frustration by finding new anthems for ourselves, finding songs with lower streams but still hits the spot for us. Across this project, we also learned that the data chosen matters. Every time we rerun our notebook, a different set of songs is generated, and this changes certain aspect of our conclusion. For example, for the ones that got away, we look to find the top 3 audio features that occurs the most frequently in our hit songs. Every time the input data changes, our top 3 features is likely to change as well. However, we learned that despite the changes, there are certain decisive traits that generally shows up in hit songs. It is more likely that a hit song will spread positivity and provide a certain amount of energy. Ultimately, we learned that different people have different tastes in music, and it is probably not possible to predict whether a song will make it big, but we can definitely give the non-hits a try. And that's all. Thank you.